Hey folks, Sean here from Grok. Let me introduce you to Grok Proactive Problem Management and Prediction. But first, some context. At its core, Grok employs a sequence of machine learning models to reduce level 1 and level 2 noise, boost productivity, and increase automation over time. It rapidly ingests and transforms diverse telemetry and uses both unsupervised and supervised learning to cut noise by 2 to 3 times more than other AIOps tools. As mentioned, it continuously learns from human feedback and autonomously selects or builds machine learning models to create a dynamic level 1 work queue that is noise-free and full of incident context. Its evolving machine learning repository not only ensures swift incident response and resolution, but also builds a series of predictive models. Even with streamlined incident identification and resolution, support teams still spend the vast majority of their time performing repetitive tasks, solving the same problems day in and day out. With the Grok Proactive Problem Management solution, these repetitive tasks can quickly be prioritized for preventative action, shrinking the volume of incidents that flow into the support organization over time. Each row in this queue is what we call a recognized detection, where each recognized detection is a uniquely observed pattern of operational data, like a group of related alarms that reoccur over time. These labels are not manually applied. They emerge from real system behavior that Grok has observed over weeks, months, or even years. Each column provides insights that describe the nature of the underlying problem. The detection ID identifies a unique, recognized detection. The occurrences column shows how many times this detection has been observed over time, which may or may not have resulted in a ticket. The incident count column displays the number of historical incidents tied to this specific detection pattern. The frequency of occurrence of a given recognized detection pattern is only important if that pattern tends to result in a potentially actionable incident ticket. Of course, this is essentially the definition of a problem. By comparing incident volumes and incident priority, a user can produce a high-level assessment of which problems to focus on for systematic incident prevention work. When a problem manager or platform owner selects a given recognized detection, they can quickly observe previous actions taken to resolve the issue and determine the best course of action. Automate, suppress, apply a soak timer, or notify through auto-ticketing. For example, in this case, the ticket almost always closes with no user action required within 30 minutes of detection. This is a classic example of a no trouble found situation. So in that case, the reasonable action would be to apply a soak timer. If each ticket was generated as the result of a particular recognized detection, the reasonable action might be to suppress ticketing for that particular problem. If, on the other hand, the problem always results in a manual ticket getting created, and upon inspection, the tickets indeed require human remediation, then the reasonable action might be to automatically generate the ticket as soon as the recognized detection is identified. For problems that are automation candidates, users can easily configure Grok to trigger automations each time an instance of the problem is observed. By selecting the appropriate detection ID, a problem manager can assign the automation most likely to restore the underlying service. Platform owners can connect their preferred automation platform to Grok or use our native automation capabilities of Grok Fix to author new automations or use an existing automation from the library. While the problem queue provides direct insights on how to prioritize activity for incident prevention work, users may need more precise insights on which incidents are most likely to occur in the near future. The problem queue provides a medium to long-term view on how to prevent incidents, and the incident prediction queue provides short-term analytics on which problems are likely to result in incidents in the near future. Platform owners and problem managers can observe the prediction queue, which indicates which incidents are likely to occur within the next 12 to 24 hours, so they can take short-term, preemptive action. Each value in the prediction window corresponds to the likelihood that the given problem, represented as a detection ID, will occur in the next 12 to 24 hours respectively. The value in the last occurrence column represents the last time this problem manifested as an incident ticket. The value in the root cause ID column represents the most likely root cause given all previously observed incident tickets related to this problem. The same is true for any information extracted from prior related incident tickets and translated into output labels from the classification model. So, in other words, for this example, we know that the root cause of this application-related incident identified as 2336 is due to a PF automation in prod as a result of the Java service going down. And we're 70% sure that it's going to happen again within the next 24 hours. If preventative automations have been created and provisioned, they're accessible here, easily triggered to prevent the next occurrence of this problem.